Okay, so where we left off was trying to calculate the y position of the center of mass. And we had talked through that our mass element is this horizontal strip guy here. So we could just write down what is a good expression for that dm. So again, we have rho dA. And what is the area element of this? There's a height dy. And then the width of this thing, which is, so if I remember right, we've got y1 of x up here, and we've got y2 of x for the lower curve. And so the width is the x coordinates of these two positions. So it ought to be x1 of y minus x2 of y. So that's the width of that horizontal strip. So that would be my mass element. And so then, to find the coordinate of the center of mass, the y-coordinate of the center of mass, and total times y, and then times this mass element, rho dy, and then these functions. Now where are these functions going to come from, right? Again, so this is x1 of y, that's the inversion of y1 of x. So you've got to invert these equations. That is sometimes tricky and difficult to do. So, but we'll do our best. And if I clean this up a little bit, if I assume my rho is constant, I can just pull it out, and I'm going to have y times x1 of y minus x2 of y dy. All right, and so again, this is the integral I've got to do. So hopefully I'm able to do this integral to be able to get my answer. Oh, I guess maybe some comment we could make on, keep talking about this m total. Well, how do I find m total for my object if it's a continuous distribution of mass like this? Well, it's just the integral of dm without any x, without any y. Right? And so that's going to be the integral of rho dA, and that's rho integral dx dy. Right? And so then you have to do this integral over this area to get the total mass. In fact, sometimes people will define, you'll see as a definition of the center of mass, you'll see it something like this, y rho dx dy over integral y, double integral, sorry, rho dx dy. Right, so this is the mass total, and then this is your moment integral there. All right, let's try an example, see what that looks like. So let's suppose we want to find the center mass of this fairly simple object. A triangular plate of uniform density, and it goes like this. And let's see, so the equation for this top line here, so y1 of x is minus a over bx plus a, so you can check slope, intercept. All right, and